Hello, it's Jay here again, and welcome to another tutorial. So in this lesson we're just going to get some things in place that again will help us when we actually come to implement scoring. So the first thing I'm going to do is actually create a floor. So let's just come to 3D object cube, and I'll reset the transform. I'll rename it to ground, and I'll also add a tag of ground. So once that's applied, we'll need to set it to -1 on the Y. We'll expand the X and Y scale, not X and Z scale to 10, and the position on the X and the Z to 0.5 each. So once this is in place, we can remove the mesh renderer. So we don't need that, we're just going to keep it invisible. Oh, of course you can make it visible if you wanted to, and maybe add a texture to it, but I'm just going to deactivate the mesh renderer. And with that in place, we're going to create a new C# script, and we'll call this grounded_check. So let's open this up now for editing. And we'll begin as always by creating the variables. Again, I'll make them all public for now. So public raycast hit underscore ray hit. So let's put this straight into the comments. Defines naming convention for the raycast hit, and we'll create a type public vector3 underscore raycast direction. Defines the naming convention for the raycast direction, and you can put in at the end here that we will put that we will control or set or something like that if you want. And we'll need a raycast distance. We can make this an int. So raycast distance. In fact, we'll set the value here. We'll make this equal to 1. Defines the distance of the raycast. And let's do, in fact, I'll put it here with the other ones actually. Public game object underscore ground. Close that off. And we'll just put into the comments variable to store the ground game object. And with that done, we can come to the void start. So in the void start, we'll say underscore ground is going to equal game object dot find game object with tag. We want the singular, not the plural. So just be aware of that. Open and close brackets, close the line off. Inside the brackets, we're going to put quote marks and the ground tag we've created. So I've set it here, tag of ground. Just be aware that all tags are case sensitive. And let's get this into the comments. So we're setting the variable to equal the game object with the assign tag of ground. So now we've got our variables in place. We've found the game object with the tag of ground and applied it to the variable. We'll actually deal with the raycast itself. So let's just create a void. Raycast check will be fine for naming convention. So once we've got this in place, we're going to first set the raycast direction, which is going to equal underscore ground dot transform dot position minus transform dot position. Close that off. Into the comments, so set raycast direction to equal the ground objects transform dot position minus this game objects transform dot position. Or you can put game object this script is attached to if you want. But either way, we've set our direction. So what this will do is I'll actually put another cube into the scene. So this cube's only for testing. You do not need to put it in yourselves, unless you just wish to try things out for now. So I'll put the cube in the scene and I'll just set a position. I'll set it in one corner. So let's try a value of 8, 4, and then just -4 on the Z. So what that will mean is, in fact, I'll move that to -3. So basically because we want the raycast coming down, no matter what rotation the block is set to, we always want it to be the same. That is the reason for setting our direction. So we're going to say if open and close brackets, we're going to say physics dot raycast, and then we'll open and close brackets. Inside this new set of brackets, we're going to put transform dot position, comma, and in fact let's enter there. We're going to say raycast direction, and then the out, which will be the ray hit, comma, raycast distance. We're going to come to the end. We're going to open and close brackets again. So let's put this into the comments. So set raycast from our transform dot position via the raycast direction so we want to detect raycast hit, by the raycast distance. And actually what we want is actually if the raycast doesn't hit. So this is how you would normally do a raycast. And normally you would do a raycast probably 8 times out of 10. You want the raycast to return when it hits something. In this case, we actually want it to return when it does not hit something. And all you need to do to change it to does not is come here just after the first open bracket and just add an exclamation point. And that is all we need to do. So let's actually put this into the void update for now. Raycast check. And we'll just put that we're calling the function into the comments. And actually we want to be able to see the direction of the raycast. So debug, and let's just use draw ray. So I'll put that debug draw ray transform dot position by raycast distance, and let's use a color dot, and I'll use red actually. So let's just come to the end there. And we'll close it off. Raycast distance, it should be raycast direction. So let's just save that off. In fact, let's just need to assign the script. Let's just pause that there. So you can see how the debug is drawing the direction the raycast will go, and it's going to the center of the floor. The actual angle will not make a difference in our game. The fact that it will have slight angle isn't going to affect us. So that is going to be fine for our purposes. Obviously it's not that long. That's just drawing to the point that we've set, the ground. But the most important thing is now, if I come to the rotation within the transform, no matter what I set the rotation to, that line does not change. It's always going to go towards the floor, and that's very important, because that is what we want. No matter what, that this raycast is going to always point towards the ground. And what we're going to do now is actually just come here. We'll create another void, and we'll just call this move. We'll just call this move block. In fact, let's change that. Upon scoring, so that's what this is going to be based on, and we're going to just call this function here. So let's just put that in there, and we'll just put that we're calling that function again. And we'll just put our normal debug.log in. And we'll just paste that in there. So let's save that off for the moment. And I think we'll leave it there for this video. As always, I hope you enjoyed this lesson. I hope to see you next time. And until then, as always, bye for now.